I'd like to welcome you all to this session about fantastic maths and being inspired by Maths Week. And I'd like to introduce Dr. Anastasia Angelpoulou. If I said that right, I hope I have.
Yes.
And I'd like to hand over to Anastasia. So welcome, Anastasia. Thank you.
Thank you so much, Helen. Good morning, children. Good morning, everyone. My name is Anastasia, as Helen mentioned, and I'm from the University of Westminster, where I teach computer graphics and especially programming using different engines like OpenGL, DirectX. And I also teach mathematics to first year and second year undergraduate students. Now, today, as you can see from the title, I'm going to talk about a very exciting topic. I'm sure that all of you love playing games. Probably you play Roblox or you play Minecraft. My son loves playing Minecraft. He loves building things in Minecraft. So we are going to see how maths actually are used in games, but in a very, very specific case study, which is actually collision detection. Okay, because collision, when objects collide, are very, very important in games. What I would like to show you here is that actually these are examples from some students that they were doing the 3D graphics programming module. So you will see two games, one in a 3D environment, and this game is in a 2D environment. What I'm doing here, probably you cannot hear the sound, but I'm just explaining to the students what actually they have to do. So this game was developed with Visual Studio, which it uses as a programming language C++, and it shows to the students what needs to be the template. So in that case, this is a 2D car game, very, very simple design. So you will see that there are some boxes here as obstacles, and you have the car which needs to start from a starting position, try to avoid the obstacles, and then finish where is the red square. Now, there is some points here, and every time that the car collides with one of these squares, then some points are deducted from the overall score. So the whole concept behind this 2D game is actually to try and move around without actually hitting the obstacles. So the other things that are happening here is that you can actually change the rotation of your car. So you can move up, down, left, right, but also you can rotate it by 90 degrees. And as I said, the whole scope of the game is actually to live without hitting any of these obstacles. And when you finish, then those 5 obstacles, they can randomize again and they can be placed into new positions. So the thing behind is how actually I can apply the collision. When my car collides with an object, how do I know that I have collision? Now, similar concept is in this 3D game, but what you have now, you have a 3D environment. You can see now you have textures which you are applying to your game. So you can have a texture about space. You can have textures for the different hoops that you have here. You can apply different textures for the crystals that you need to collect. This 3D game is, again, you are a spacecraft and you need to move around those crystals and collect the crystals. So again, you need to have collision to understand the collision between the crystal and your player, which in that case is your spacecraft. And after you have collected all the crystals, then again, the game ends, you randomize it, and at the top here, you have some information about how many crystals you have collected, for example, and all these things. So now, we have to see actually collision detection. What are the things that we need in order to have collision detection? So in order to make sure that we have collision detection, we need to know 2 things. Let me change here. let me write here, what are the things that we need to know? So the first thing is that we need to define the boundaries around our objects or characters. So imagine I'm going to do a simple drawing. Imagine you have a cat. I'll try to make a nice cat. So your cat looks like that. Excuse me for my drawing, but I'm doing my best to make it look like a cat. And what you need to do, I need to make a 3D shape around this cat in order to define the boundaries. So I'm going to make a 3D shape of a hitbox around my cat. And as you can see, the first thing is that I need to define these hitboxes, as we call it in games. Now, those hitboxes for you, they are shapes like cuboid shapes. Okay, so in this particular example, based on my object, I decided to create a cuboid shape around my cat, which is known as a hitbox. So that's the first thing that I need to know when actually creating and try to identify collision detections. So the second thing now that I need to do is I need to identify which other objects collide with my player. So if we go back to my same character, and again, I have, let me make again my hitbox. Imagine now that I have another cat, for example, that is standing like that. And I want to know if there is, again, collision with this particular cat. So again, I will have to create another hitbox or a cuboid shape around my cat. And then identify, for example, if those two boxes collide or not. So what will happen after the objects have collided depends on your games. And this is known as collision resolution. So the result of the collision is known as collision resolution, and depends what you want to do. For example, in the 2D car game, as we discussed before, I may have my car going back a little bit when it actually hits a box, or my collision resolution may be send the car back at the starting point. Or when, for example, your car hits one of the boxes, you may want to change the color of your obstacle. So this is the result of collision resolution, where you identify what actually you want to do with your collision. I'm sure you all know this player from Minecraft, okay? You can see how we have created now a hitbox in the form of a cuboid shape around the player. Now, because the Minecraft players, more or less, they are very, very blocky, you can see that a cuboid shape is very, very appropriate for this particular example. But there are other objects which the cuboid shapes are not the best shapes that we can use, but we can use, for example, cylinders, we can use spheres, so we can use other type of shapes around our objects. Again, this is another example here where now you have more players, and for every single character, object, or player, you need to create those hitboxes. And you can see that on top of those characters, you also have the health, but you don't have to include that in your hitbox. So the health means that it's going up or it's going down based on the collisions. What you're interested is to know if there are collisions between your hitboxes. So now, collisions and the different methods that we can use. Based on the different shapes, you will see that my collision will depend on the geometry of my object. Now, in my game, my object could be a single point, it could be a line segment, which may represent a wall in my game, or it could be specific shapes, for example, spheres, it can be triangles, it can be cubes, it can be any type of shapes that I like. Based on the geometry, we can either go for a circle or in a 3D, we can go for a sphere. Again, we can go for a square, or we can go, for example, a cube. Where there are orientations, we can also use orientation of the bounding box. That's what it stands for. BB here is orientation of the bounding box. Or I can go along the shape of my object. Now, AABB is exactly the same, but here it means axis aligned because I have alignment on the X and the Y axis. And again, based on your object, you can choose any of these objects. There are also some new methods where I have put a YouTube link here, where now instead of sphere or cuboids or any other methods, you can use actually some more interesting and advanced methods to describe your objects. So as long as it takes to load up, I will come back to that video when it's loading. We will see it later on. Let's discuss now about circle-to-circle collision. So this will be the topic of today's collision. So imagine in a 2D game, what you have an asteroid, that's the shape of your asteroid, and you have a spaceship, which is a triangle. In order to identify collisions,
Lost your sound there, Anastasia. Are you okay? Can you hear us okay?
yes, I can hear you okay. It was the video that actually started automatically.
Oh, okay. Okay.
Okay. So I will stop the video because briefly, I just wanted to show you the different methods that can be used. So while we discussed about circle and sphere to sphere, so this is a capsule to capsule collision. So you see it has some rounded areas around your object because your player now you need to have more accurate areas. I just wanted to demonstrate that there are different methods and this is a more advanced method, the capsule to capsule collision, which gives more accurate results. So going back now to our presentation here. The circle-to-circle collision means that if I have an asteroid and a spaceship, I need actually to creating bounding circles around my objects. So I need to identify what is the center of my object, what is the center in my triangle, what is the center here on this shape that I have. And then based on that, I need to create a bounding circle around my object. So this is the bounding circle of the spaceship. This is the bounding circle of the asteroid. And then in order to identify if those two bounding circles have collided, what we need to know is to calculate the distance between the centers of the circles. So based on that, we can identify if now we have collision or not. So if the distance is less than the sum, which is the addition of the two radius, then I have collision. So if we would like to see that visually and try and draw it and see how this will look like, what actually we have here is that imagine you have your circle here for one object. So this is the center of your circle and you have the radius for this first circle. So I can call it R1. Then I have another circle here of my second object. So again, it has a different center. I have another radius for this particular circle, which I call it R2. And then I'm taking the distance, which is the distance between 2 points between the two centers. So now, if the distance is greater than the sum of R1 plus R2, which is the radius for the first circle and the second circle, then we say we have no collision. But in the case where my circle is like that and my circle is like that, so again, I'm taking the radius for my first circle, R1, I'm taking the radius of my second circle, R2, and I'm calculating the distance again between the two centers. So you can see here that the distance between the two centers is less or equal than the sum of R1 plus R2. So in that case, when these things happen, then we have collision. And this is what we are actually checking when we are applying collision detections. I don't want now to show you the full formula for the distance, but it comes from Pythagoras theorem, it comes from a right triangle, and actually it is a square root of the difference between 2 points. So that's the things in reality that we check in games when we want to apply collision. If the distance of the two centers is less or equal to the sum of the radius. And you can think that you can expand that into 3D environment because now I'm talking about spheres and not circles anymore. So when I have a 3D object, like we had actually with the Minecraft, instead of having a circle, I need now to create a sphere around my object. And similar here, your objects can be made of many different triangles. I can create a sphere around the head, for example, of this particular player. So now, going back to our character, I will try to draw again my character. We are going to see some problems that we may have with this object. So imagine that I'm referring to my nice cat here. Again, I'm going to make a cuboid shape around my cat, which is a hitbox. And you can see the problem actually that I have is that I have some space here where actually there will be a false collision because it's an empty space. So you can see, let me write that down for you. You can see we have a lot of empty space around the player. Which still, this will be counted as collision. So when you have another object coming closer to your cat, when those two boxes collide, then this will be a collision. However, this will be with an empty space. Is there a way to overcome that? Yes, there is a way to overcome that. And what we are actually doing, the solution to that, is that what we do, we make a lot of smaller boxes or spheres, as you can see here, around the objects or the players. So in the left-hand side here, in that particular image, you can see that each player that I have here has been split into smaller cuboids. So instead of having a big cuboid around my character, as it was with Minecraft, what I have done here is that I have a lot of different cuboids, one for the head, another one for the arms, smaller cuboid objects for the wrists and the hands, and for the legs, for the feet, and so forth. And the same concept applies also to the player on the right-hand side. But in that particular case, because my player here, it's a very curved player, so it has a lot of curved areas, instead of using hitboxes, I'm using different shapes now. So you can see I'm using shapes which are more spherical, which they're more like spheres, cylinders, so this type of objects. So based again on the geometry, either I can use cuboid shapes for my players, and I can use many cuboid shapes, or I can use many different spheres or cylinders. And the question is, what do we do with that? So after we have created that, the concept behind is we create a hierarchy of all these different objects in order to identify the collision test. So instead of having only a circle or sphere around my object, I create smaller spheres around this bunny, and then based on that, I create again smaller spheres. And what I actually built is like a tree. So imagine the node, the top node of your tree is the bunny here, and then you have a lot of different children, as we call it. So that's the parent, and I have a lot of different children which might go like that. One of these children, for example, may be the ears of the bunny, which actually I split it into smaller circles, and then this can be another node here, which is split into different smaller nodes. And again, this can be another node, which is split into smaller nodes, another node, and so forth. So the whole idea behind the hierarchical collision test, as we call it, is that we build a tree. And this particular tree, it has a single node, which is the parent, and then it moves down to children. The same concept can also be used when we're applying hierarchy in the game level. So imagine my entire level can be this type of game, where what I have here, I have some boxes, for example. So these are some boxes that I have there. I have one box here. I have another box there. I have some players here. For example, I can have one cat, I can have another cat there, and so forth. I may have some houses here. And I may have some flowers. So imagine this particular game level, it has these different features. So the concept of keeping a hierarchy in the game level, or actually building this tree, is that what I can do is that I can say, okay, let me split this game level into left and right. So my top node can be the entire level. So I can write here, my entire level is the whole game level, and then I can split it into two, which one refers to the left and the next one refers to the right of my game level. And then based on that, I can further split this game level into up and down, and I can say that, okay, the left is going to be split into two more nodes, which is the up, and this one is going to be the right one. And I can do exactly the same for my right node, which is going to be split into up. And again, it's going to be split into right. Sorry, up and down. So let's correct that. This is down here that I wanted to write, and similar. Let's correct that. This is down. Okay, so up and down. So now, what do we do with that? We can say that if I know where actually my objects are in my game level, then I can start not going further to other nodes. So if I know that the only things that I'm looking at for collisions are things that collide for boxes and for the house, then everything which sits on the right, I can ignore it. Okay, so I don't have to look at that. And again, if I know that what I'm interested in as well is only on the top, so I can ignore this part, and then I'm interested only whatever refers to the up of my level, then again, from the left, I can ignore this one, which is the down. So this hierarchy saves a lot of computation because I don't have explicitly to look all the different objects, but based on what I'm looking at, I can actually prune my design, I can prune my programming and focus only the areas that I'm interested in. So this is known in games as pruning. So if we would like to sum up about game developer skills, what is used in games, what we need in games, my sum up will be that a game programming job or a game developer job, so game programming or developer, whatever you prefer, then first of all, you need programming, so you can use C++, you can use Java, you can use Python, you can use any language which is machine-based language for your games. And the other important aspect that you need is you need to know the maths, because if you don't know what is the maths behind a collision detection, like circle with circle, that in circle with circle, I need to know the distance between two centers. And based on that, I can calculate if the distance is less or equal to the sum of the radius, then you will not be able to put that into your program. And I have here again another video which actually shows you those different collision detections. So what you can see here, you have actually the two boxes that you have. So you have your box of your object here, it's moving up as well, but you can see that whenever, for example, my object is moving left, right, up or down, nothing is happening. When my object has already collided with the other square, then the color changes to green. And as I said, this is actually the collision resolution. So based on that, what you can see is this program actually, and especially in the collision detection with circle to circle, it uses these mathematical formulas here that we just discussed. We need to know the distance, which is the square root of the difference of the X and the Y points. And then we need actually, in order to have collision, if the distance is less than the sum of the two radius, then we have collision. So that's the way that you need always to be able and put into practice your maths. And I will stop here, and I'm more than happy to take any questions you might have about collision detection and how maths are used in games.
Thank you so much, Anastasia. I have got a couple of questions that come through. There was a great question that came through first from a school to say, why can't we see the hitboxes within the game? So obviously that's obviously buried in the background, isn't it? And don't forget, we're talking to year sixes here.
Yes,
so.
exactly. The developer always create the hitboxes, but when you render the final scene, those hitboxes are invisible because there is no point to show to the player where those hitboxes are. Those hitboxes are only used by the developers in order to be able to apply the collisions to the object, but then you make them invisible, so you don't see those hitboxes. Because it will be really, it wouldn't look nice in the games when you're moving around, imagine in Roblox or Minecraft, to see around the Minecraft player all these different hitboxes. You will actually lose the fun of the game. But the developer needs to know where those hitboxes sit in order to be able to program everything.
Yeah, that's great. You don't realize as well when you're playing a game that all that is happening behind. So it's really good to have that explanation.
Exactly.
Yeah, with understanding the different ways that you can put the hitboxes around. There is one question that come through. I'm not sure if you could answer this or if you have answered this, but it depends on how much you know that's in the curriculum for this year group. So is to explain the links to maths, which you did at the end slightly, and understanding the distance and the radius, but I'm not sure if, can anyone answer this question in the chat? If you've covered anything with radiuses, and I know you do shapes, and I know you understand what spheres are and cuboids, but has anybody covered Pythagoras, or would you do that in the secondary schools? I think that might cover in secondary schools. Does any teacher answer that for me? That would be great.
What everything it comes, I don't know if they have done that at school, but actually what you're doing when you're taking the distance, if we consider a right triangle, okay, and this is A, this is B, and this is C, we know from Pythagoras that C squared is equal to A squared plus B squared. So we do exactly the same here because the distance is between the two centers, x1, y1, and here is x2, y2. So now my distance D is going to be the square root of the difference. So x2 minus x1 squared plus y2 minus y1 square. And that's how I calculate the distance between the two centers of the circles. Okay,
yeah, so
just to give them the full formula, that's the formula behind it's the square root of the square of the difference between the 2 points on the x-axis and the y-axis, because everything, imagine, sits on a 2D Cartesian coordinate system. This is my x and this is my y.
So I don't think they cover that as much. They've touching on it with the radius by the sound of it, but they're not going into the Pythagoras theory yet. So yeah. I know they do square roots. You do square roots, don't you, in year 6? But that's quite a complicated maths equation, but you can actually see how it works. And I think the children probably will see going forward how that it would be starting to develop when they're going to secondary, but they are touching on it. So you've got the right hand triangle, so they all would have known what a right hand triangle is, and the A, B, and C sides, etc. So I think
I hope they will remember me when they are going to the secondary school, that when they're going to use the Pythagoras theorem, for example, which the C is actually square root of A squared plus B squared, then they can relate the two and they can say, distance, how distance is used in games for collision detection. So they can have an application of the distance formula in collision detection.
Fantastic. We've got a couple more questions here. Moving on from those, have you made a game before or helped to make a game? So this is you directly.
Yeah, I mean, I helped to make a game, which was an online game. So it wasn't a platform game with some contacts that I have from industry. So it was an online game that we used WebGL in order to develop the game. I have developed games myself for my students. So the games that you have seen before, those videos here, actually, I ran those games first in order to see, I have developed actually this one, and I pass it to the student. This is how your game should look like. So from that point of view, yes, I have done games, not in the scale of Roblox or Minecraft, because you need a full team behind to develop such big games. I mean, you need to have artists, you need to have game level designers, which is different from game artists. You need to have audio people. You need to have a lot of programmers as well. You need to have a producer. So it's a full team behind such big games. It's not only one person's job. So, but you have at least 50 or 100 people developing such massive games.
What a great team to be part of, hey?
Exactly.
This is a really good question from our year 5 student. What level of maths do you have to study in order to become a game developer? So that's a really good question, Alistair. Well done.
Yeah, that's an excellent question. In our university, I can talk for our university, we sometimes ask for A levels. But even at GCSE, but with a good grade at GCSE A or B, still we take some students and we try actually to boost up their math skills from year 1 to year 2 and year 3. For example, the computer games programming degree at University of Westminster, it has 3 years where we're doing mathematics. For example, we do maths in the first year, then we do physics in the second year, because games, they need physics. They need to know about projectiles, to know about gravity, to know the Newton's law and how you actually put that into place. Like imagine Mario without gravity, okay, Super Mario or other players, then they will be floating. And then we have more advanced maths at level 3, which is the third year, at level 6, which is year 3. So for the University of Westminster, throughout the 3 years, our students, they're doing mathematics.
Right, okay. I hope that answers the question. So if you're really interested in doing anything to do with computer gaming, then maths is definitely one to keep on board. Yeah. So keep studying your maths, even at your level, keep at it. So that's really good. Thank you, Anastasia. I've got one question here. We would like to know, how do you debug it if it goes wrong?
Again, this depends on what type of programming you're using, what type of engine you're using, because there are a lot of different engines where you can actually first put a prototype of how your game looks like. But in Visual Studio, first of all, when you start to debugging, when you compile your game, it will give you errors if something is wrong. Okay, so for example, if my programming is not what it should be, then when I try to run it through Visual Studio, I will get a few errors where I will have to go back, debug it, and see where my problem is. Either it is syntactically, for example, it means that when I'm typing my code, I may have missed something, or maybe whatever I'm writing here doesn't make any sense. Okay, so I'm not seeing the result where I'm supposed to see the result. Okay, so that's the way that you debug your programs. And again, depends on your environment, what you're using. If you're using your IDE, Visual Studio, Eclipse for Java, or engines like Unreal Engine for putting prototypes of your games.
And I suppose that applies to someone's just asked a question about virus in your game. So it's having the right software, really, isn't it?
Yes, yeah, generally, yeah.
Coding of games is incorrect. How do you change it? So it's the same sort of answer, really. If you've got any more questions, we've got a couple of more minutes. So I know some of you are desperate to go back to lunch. So if you've got any more questions that you'd like to ask Anastasia while she's here, thank you so much, Anastasia. What a great topic.
I hope they enjoyed it. I hope they find it useful.
Yeah, I hope it wasn't too...
my only thing is that, guys, keep working on your maths. Maths are very, very important for whatever you choose to do in your life. I'm sure you have seen from other presentations, from very simple tasks, you need to know your maths, from numerical maths up to more advanced maths. Now, if games is something that interests you, yes, mathematics are very, very important as well. Okay, and depends again, if you plan to build chess game, then these games should also have probabilities. So again, the concept of probabilities applies to games as well. So it's not only algebra or geometry. We need probabilities as well.
There's a couple more questions here. How long does it take to program a game?
Depends. Depends the game. How complicated or how easy the game is. So depends, there are numerous factors. Again, how big or how small is the game, how many levels the game has, if it has only a single level or if it has 100 levels, I don't know, depends if it is 2D or 3D as a game, depends the design, the level design. For example, if you have many objects that you put in your game and you're looking for a lot of different things. So yeah, I mean, as I said, this is normally all the professional games, there is a full team behind and takes them months to actually develop the game, draw the game, test the game. Don't forget, testing is a very, very important aspect of the game as well. And as a job, you can be a tester, a game tester, which is a very good paid job as well, where actually those people, they take the games and they test it extensively for bugs, for code, for example, that pops up where it shouldn't pop up, or for other things. So testing is again very, very important in the game production as well.
Fantastic. I think we've got time for one more. How would you create a computer AI in a game? Oh, there's also another one. How do you make 3D games? So I think they're quite an advanced, that's quite an advanced question, isn't it? So
the 3D games, I mean, the 3D games, it's not something more advanced than a 2D game. So depends how you're setting up your camera and how actually, if you have a 2D game, so actually you ignore the third dimension. So it's like sliding from one frame to the other. While when you develop 3D game, you give this depth to your game world. So actually you set it up in a 3D Cartesian coordinate system. And then you apply extra things like, for example, as I said, instead of using 2D shapes, you're going to use now 3D shapes around your object. So you're going to use spheres, you're going to use cylinders instead of circles or instead of boxes. So the 3D game, it's nothing more advanced than the 2D game. It's the perspective that you're changing. The camera, now you have depth in your world. And of course, you now need to navigate in all three directions. So it's not only X and Y, but it is X, Y, Z. Okay. And then all the games, whatever you see here, these are textures. So these are extra things that you're applying to the game, which has nothing to do with the geometry of the game. This is lighting. You can add lights, you can add fog, you can use, for example, shadows, shades. So all these extra things are part of the rendering of your game. To go back now to the other question about AI, artificial intelligence, yes, you apply AI. There are specific algorithms, for example, that you can use for AI. One of these is pathfinding in games. So you have the character, you have the enemy that chases you, a ghost, for example, and then the ghost tries to trick you by taking the shortest path and try to identify you. So these are different algorithms, like the pathfinding algorithm, that can be used in order to make the game more clever and actually make it more difficult to play. Because when you add AI into your game, you actually make the game more difficult, more challenging to play.
Great, I think that's it. I don't think we've got any more. South Hill, are you in Hertfordshire, South Hill? If you're still with us, South Hill, I know there's a South Hill Primary in Hertfordshire. If you are, then you can get in touch with me afterwards. I think that's it. There's no more questions here that we've got. South Hill have asked, are there any coding programs that they can use? And I've suggested the BBC Microbit, because their website's quite good, isn't it?
Yeah, and yeah.
they can do it on the website as well. They don't actually have to have a microbit either, do they? So
exactly, yeah. And as you will move later on, those of you that you will move to the university, I mean, you will see that especially the games, the programming language for games is C++. Okay, so that's the main programming language, because we want to be as close as to machine programming, since games are very computationally expensive. So they actually, in order to have your players in real time, you need to be able to program at very low level programming. So C++ is the language, the programming language that is used mainly in games, especially platform games for PlayStation, Xboxes, all these, they're using C++.
What's it called? SIP? What's
C++.
it called?
I can write it here.
Write it in the chat. Write it in the chat. So that'd be great. So then we've got it in the chat. So if anyone sees it there. So if they've got any more questions from anybody, that would really, otherwise we'd wind up the session. Oh, C++. Oh, that's simple. Okay.
Yeah.
Okay, so Anastasia has just written in there. So have a look at that, search that on the website and see whether you've got anything there you can help with. So yeah, thank you all for joining us today. I know that you're probably, thank you.
Thank you.
Yeah,
I hope you enjoyed it as much as I enjoyed preparing it. It was much of fun for me.
That's great. Thank you, Anastasia. It's really good.
Thank you, everyone.